90% of the students get this question wrong, even after studying the carbocation stability. Because this question is not testing the degree, but the geometry of the carbocation as well. Here we need to arrange these compounds in the decreasing order of reactivity towards SN1 reaction. As you know, in case of SN1 reactions, there is the formation of a carbocation. So, without looking for the reactivity of these compounds towards SN1 reaction, we would look towards the stability of the carbocation generated here. So carbocation stability will decide which compound will react faster towards the SN1 reaction. So greater the stability, greater is the ease of its formation, and higher is the reactivity of that compound towards SN1 reaction. Before discussing further, let us first check out that when we are removing the bromine atom here, the 4 carbocations generated are like this. This is the 1 carbocation, this is second carbocation, this is the tertiary butyl carbocation, and this is triphenyl methyl carbocation getting generated here. While solving the stability order of these carbocations, let us remember the stability order rule is that resonance is at the top. It dominates in stabilizing the carbocation, followed by the hyperconjugation. And after that, it is the plus I effect. After that, it is degree. And last but not the least, it is the geometry. And understand it and remember it that the geometry can override the stability of a carbocation, because it is the geometry which decides whether the planar carbocation is getting generated or not. If planar carbocation is not generated, that means that carbocation will not get formed. Okay, so now let us see these carbocations. Okay, so we are using the elimination method rule to solve this question. So this is the carbocation of the third compound, this is the second carbocation of the second compound, and first carbocation of the first compound. As you know, this is a resonance stabilized carbocation, and here already I have told you that resonance is having a dominant effect on the stability of a carbocation. So fourth one will be maximally stabilized. I can show you it here also. This is a carbocationic carbon. It is attached to the phenyl rings here. This side also it is attached to the phenyl ring. So what it does, these phenyl rings show positive mesomeric effect, या resonance effect भी कह सकते हैं, and because of the positive mesomeric effect, this positive charge gets delocalized over these phenyl rings, resulting in its maximum stabilization. So first one, using the elimination method, that means that the fourth one will be the first option, will be the maximally stabilized, and it will show faster reaction towards SN1 mechanism. So let us look which one will be here the option. So here the fourth option is in option first and option fourth. Second and third will get eliminated here. Means that using the elimination method, we can eliminate the second and third option. So either option will be first or option will be fourth. Now from the options, it's clear that the second option is the third one here also. So that means it is common in both the two. If you see here, the third one is the tertiary butyl carbocation, and yes, tertiary butyl carbocation is the second most stabilized one. Why so? It is because it is stabilized by hyperconjugation. You are already knowing about this fact that tertiary butyl carbocation contains 9 alpha hydrogens, and hence it is maximally stabilized by hyperconjugation. So hyperconjugation is what? It is the donation of the sigma electrons into the p orbital of the carbocationic carbon, and that is actually the hyperconjugation. And this hyperconjugation stabilizes this tertiary butyl carbocation. That is why it comes under the second place, but it is common in both the options. That means the deciding compounds here are the first and the second compounds. So let us look into the first and second carbocation is generated here. Now the main answer lies in solving the stability of these two carbocations. Now if you look the stability of these two carbocations, Let us analyze them first. Both the first and the second carbocations, they are bridgehead bicyclic carbocations. That is why I told about the geometry. Here the geometry decides that which carbocation is stabilized. Both are bridgehead bicyclic carbocations. Here this is a bridgehead carbon, this is a bridgehead carbon. They are actually bicyclic compounds. So if you see, they are bicyclic compounds. Okay, the positive charge is generated here is on the bridgehead carbon, so they are bridgehead bicyclic carbocations, and here the positive charge is generated is on the tertiary carbon. So maybe students will assume that both may be of equal stability, but it is not the question of degree, but it is the question of geometry here, which allows us to tell which one is more stabilized. If you see here, it look like this way. I can show you. It is this. It's like this. So here this positive charge is generated on the bridgehead carbon is the part of a small bicyclic system. So since this is a small bicyclic system, it is highly rigid and it does not allow positively charged carbon to achieve planarity because of the severe ring strain. That is why this carbocation becomes less stable. Whereas in case of this compound has 6 carbon atoms in the ring. So when it is having 6 carbon atoms in the ring, so it would be having a greater ring size. So this greater ring size provides more geometric flexibility, allowing the carbon to approach planarity. That means this first carbocation becomes more stable than the second one. So hence the order of reactivity towards the SN1 reaction of these compounds follows as fourth, greater than third, greater than first, and greater than second. So now, which one is the option? Then that option is fourth, third, first, and second, and that is the first option. So first option is the answer. So tip to follow is always remember that never trust carbocation degree blindly. Always check whether the structure allows planarity or not. If you want a deeper conceptual understanding, I will be uploading a detailed explanation very soon. And if you still have doubts, drop them in the comments. I will be happy to address them. Thanks.